Hello, geometry students. We are starting Unit 5, which is on similarity. So we're going to see a lot of algebra in this unit, a little bit of proofs, and then, like a combination of both. So today we start with just the idea of what are similar triangles, and then what properties do we know about them. So on the next page here, first thing to take note of is it says similar triangles are the same blank, but not necessarily the same blank. All right, well, we're talking about they are the same shape, but not necessarily the same size. And so when we state that triangles are similar, there's a symbol that goes with that. So the symbol for similar is just that little kind of squiggle guy, the top of the congruent symbol, basically. All right. So when you look at this very first example, all right, here's a perfect example of where you can see that all the angles are exactly the same. So 20 and 20, 110, 110, 50, 50. So corresponding angles are congruent, or of course you can say equal. Either one of those will do here, right? And then as for the corresponding sides, well, if we look, this side here, AC, would correspond to side A prime, C prime. Right? From 5 to 10, the numbers are doubling. And if you look, side BC and B prime, C prime, you got that same scenario. It goes from 3 to 6, bottom side from 7 to 14. So what we would say here is that the corresponding sides are proportional. And we'll show exactly what that looks like in a moment. But the idea is basically the side lengths we're going, times 2. Right? Or it's another way to think of it. It's a dilation of the first. All right? So bringing back in some other units. Sliding on up here, it says show that the two triangles are similar by demonstrating that the sides are proportional. All right, to demonstrate that the sides are proportional. If I show something's proportional, I'm showing that the ratios are equal. So we want to show that the ratios of the corresponding sides are equal. That's kind of the goal. That's what they mean here. So if you look at this, this is labeled nicely. You have D, E, F, and then D prime, E prime, F prime. So that makes it nice here. So if we compare, let's say, the side DE to D prime, E prime, just fill in the blanks. DE is 6, D prime, E prime is 8. And then we could look, let's say, at the next side, EF, and that we would compare to E prime, F prime. Oops, I'll slide up a little there. And that would be 9 to 12. And then the last one, if we compare side DF to its prime, D prime, F prime, we're looking at 12 to 16. All right, what we want to show is that those are all in the same ratio to one another. So to do that, just simplify each little fraction. 6/8 would reduce down to 3/4. 9/12, that reduces to 3/4. And then 12/16, divide each by 4, that reduces to 3/4. So if we're getting the exact same ratio for all three parts, then that shows that the sides are proportional. The other way to show that would be to show that if you actually set up like a proportion, so 6 is to 8 as 9 is to 12, you could actually quick cross multiply and show that, like, hey, 8 times 9 is 72, 6 times 12 is 72. That would be another way, if you show the cross products are equal, to show that those values are proportional. So you're either simplify to show equal ratios, that's one way, or you can set up a proportion and show equal cross products. Either way. All right. And then the last little detail that we want to add to this page is the idea of a similarity ratio. So similarity ratio literally is just the ratio of a pair of corresponding sides of the similar triangles. So if we look at a pair where we compare one side and then it to the corresponding side, whatever ratio that comes out as. So 3/4 would have been the similarity ratio here. Now keep in mind, you can write the similarity ratio as 3/4. You can write it as 3 to 4 like that as well. Either one's fine. I probably would show it this way, but just saying. All right. Flip it on over to the next page. Let's talk about how we actually use this to solve for some missing pieces. So you need a calculator, maybe some colored pencils would be helpful. So it says here, given that triangle ABC is similar to DEF. So right off the bat, what that means is that the angles, corresponding angles are equal, but in this case, we're focusing on the sides. So that means the sides are proportional. All right. Find the value of X and then find the lengths of DE and DF. So something to keep in mind here, and this is where I like using colored pencils, but you don't have to, is the order of the letters matter. Right? So what I mean by that is if I want to say like which sides are proportional, you might be able to just look at it and tell. But if you can't, then you can say like, all right, here's AB. That's the first two letters. That should correspond to the first two letters here, DE. So it corresponds to that side right there. All right. And then if I have side AC, that's the first and last letter. So this right here, that should correspond to the side given by the first and last letter there. So D and F. If you don't have different colors, even just make a zigzag on one line, straight line on the other, whatever works, right? And then you can set up a proportion from here. And there's actually multiple ways to set up a true proportion. So something to the effect of showing like AB, I'll just kind of throw it over here. AB is to DE, so the blue to the blue, and then I can say is the red to the red here, you know, AC, and then is to DF. Keep in mind, I've got the one triangle on the top, other triangle on the bottom, so just be consistent with your setup. So now if I plug in for those values, I would set AB to DE, so 9 to 2x plus 1, and then my other length, now I'm going to go AC to DF, so 12 to 3x minus 1. And in our solving, we are cross multiplying. So when we cross multiply here, remember a couple of things. We are multiplying and setting those products equal to each other. So that's going to give us 9 times 3x minus 1, and then equals 12 times the quantity 2x plus 1. If it's a binomial, please put parentheses around it, and then equals goes in between here. From there, distribute and solve. So if we distribute, this will give us 27x minus 9. Over here, that would give me 24x plus 12. And now you're just cleaning things up. As a reminder, when you're moving across the equal sign, we're using that opposite operation. So I'm going to kind of multitask here. That gives me 3x on the left. This is going to give me 21 on the right. Divided by 3, I get x equals 7. So the question, when you go back and look, said find the value of x. All right, bam, that part's done. And then find DE and DF. So last part, just plug in. So DE, we got 2 times 7 plus 1. That'll give you 15. And then DF, we have 3 times 7 minus 1. That'll give you 20. You do not have to, but you can absolutely like check your answers to see if it makes sense. So this is 15. This guy was the 20. So it should make sense that 9 is to 15 as 12 is to 20. I can reduce each of those. So like if I reduce it, divide by 3, that would give me 3/5. Divide this guy by 4, that would give me 3/5. So I'm good to go. And that 3/5, that's my similarity ratio. So in case you see that question thrown in there, that's what that's talking about. All right. Same idea. This next one, a little bit different because you have the triangles on top of one another. If you look, you have triangle ABC. So ABC is the big triangle here. And then triangle ADE, that's kind of the little triangle inside of it. Anytime we have overlapping triangles, just like in our proofs, I think it's a good idea to redraw them. It doesn't have to be fancy. You can do it fairly quickly, but I think it helps to see it, especially when we go to label. So what I mean by that, the little triangle, that's X, that's 10. So nice and easy. The bigger triangle, that full length, is now the sum of those two pieces. So 6 plus X, or I like writing it as X plus 6. So that would be this here. And then the bottom of it, that's going to be our 25. So now when you're looking at it, hopefully it's pretty simple to see that, right, AB is to AD, first two letters of each. So AB to AD. And then BC is the second two, DE is the second two. And again, something as simple as if you don't have different colors, just kind of drawing it a little differently so you can kind of visually see what matches up. All right, set up your proportion. So many ways to do it, as long as the parts correspond correctly. So what I mean by that, if I go big triangle to little triangle, I can go X plus 6 to X. Then over here, it needs to again go big triangle to little triangle. So 25 to 10. So just be consistent with the order, all right? And then once you've got it set up, from here, this should definitely be some Algebra 1 review. So I'm going to get 25x, and then you're going to multiply 10 by that binomial. If you can do it in your head, great, but it's always a good idea to show it so that you don't lose anything in the midst. And then we can solve from here. So move that 10x on over because we're moving across the equal sign. So we get 15x equals 60. Divide by 15. You're going to notice most of our answers are nice and pretty. It is okay to get a fraction. It's okay to get a decimal. If it's a really nasty looking decimal, maybe double check your work because that might be a sign that you set something up wrong. This one just asks for x. And you're done. That's it, right? If it had asked what's the similarity ratio, then we would just say something like 25 to 10. We could have answered that right off the bat right there. All right. Let's flip it on over. I'm thinking we'll save some of these to recap in class. So with that being said, let's skip number 3. We'll save that one for a recap. So write yourself that little note right there. Right? And then let's take a look at number 4 together. So I'm going to slide on up. This one, I like this one because it's a lot of algebra going on. It's a great review question. So it says, given the following diagram, find the length from A to C. Oops, and it looks like we're missing a little something. So the little something that we're missing here, let me add it to the top, is that triangle ADE is similar to triangle ABC. That is kind of important right there. So add that to your notes. All right. Once again, you have one triangle and then a larger triangle. I would strongly suggest sketching off to the side. So here's my ADE, where this is 2, this is X, and then I've got the bigger triangle of ABC. And now put all that together. So that full length, X plus 1 plus 2, is really going to be X plus 3 here. And then this full side length, you're adding those together. So X plus 6 would really be 2X plus 6, just like that. And now you can set it up. If you like using the colors, use the colors. If not, stick with your pen. But otherwise, AD, first two letters here should match AB here. So AD to AB, just like that. So we can say 2 is to X plus 3. And then you've got the side AE marked. So AE is first and last. So that should match to first and last here. So a lot of these, you're probably like, I probably could have just looked at that and figured it out. Occasionally you will get one where the diagram's kind of twisted or turned upside down. And that's why I go through showing you which parts should match here. All right, we're going to have over here then X and then 2X plus 6. Here's why I wanted to do this question. Now let's do the algebra. We've got 2 times the X, 2X plus 6, and X times the X plus 3. I'm going to do the X times X plus 3 first, and then the 2 times 2X plus 6, only because right here, that's going to give me an X squared. plus 3x. And I just want it on the left side because I do. It wouldn't be wrong if it was the other way around. All right, this will give us 4x and then plus 12. Okay, we've done a little bit, teeny tiny bit with this year. Just solve a quadratic. If there's just an x, we could take the square root, but we've got other x's in here. So our goal step here, this is algebra 1, just FYI, is we need to get it so that it's equal to 0. And then we are looking to factor. All right. So I'm going to move everything over to the x squared side where x squared is positive. So subtract 4x, subtract 12. All right, that's going to leave me with x squared minus x minus 12 equals 0. So the types of factoring you know GCF, you know difference of squares, and in this case, this is the add multiply guy. So trinomial factoring, you're looking for what adds to the middle, multiplies to the last term. So when we think of factors of 12, 12 should just be 3 times 4. I want it to add up to -1, so make it a -4, positive 3, and then let's solve. So split it apart. X minus 4 equals 0. X plus 3 equals 0. Hopefully you're like, yeah, this is all coming back to me as we're going through it. And then we get x equals 4, and we get x equals -3. Now, sometimes negative answers have to get rejected. So you got to go back up and look at the diagram and see if we can have x be negative. So if I come back up here, if you look at the diagram, x itself is the length of one of the sides, like side AE here, and that can't be negative. We don't want any negative lengths. So in that case, yeah, we're going to reject that answer because AE cannot equal -3. It just wouldn't make any sense. So that means our value of x would be plain old 4. And then if we go and solve for those missing side lengths, then that means that AC, excuse me, AC is the one we're looking for. AC is the 2x plus 6. All right, well, that means 2 times 4 plus 6. So we get 8 plus 6 or 14. That's the final answer there. All right, so that's a lot of algebra kind of hidden inside of a little geometry question there. All right, on the last page, there's a couple more here that can be done for some practice. We're going to hold off on maybe doing a little review or recap in class. All right, please make sure that you answer the post video questions, and I will see you guys soon. Thanks.